wrong piece of the previous two clauses in the sentence, you're not going to understand the sentence. Right. So it's actually not always the technical words. It's the structure of the sentence which is throwing the kids. So helping students really read, and all the strategies you learn in English language arts classes don't work for reading those sentences. Because you cannot speed read or get the general sense of the sentence and make any sense out of it. So in fact, when I read physics, I read a lot slower than when I'm reading a novel, and I read differently. And I need somebody to teach. I needed to learn to do that. Or I take my strategies and apply them to the science textbook. They simply don't work. Thirdly, the whole idea of words that express a complex idea. Take deforestation. There's a whole story in there, right? Somebody cut down the trees, and it led to the fact that this land doesn't any longer have trees on it. Well, that's not just one word, that's a whole story, right? So, and science tends to do that. We invent these words that tell whole stories. And recognizing the structure of words where nouns can have whole stories involved in them is worth talking about in the classroom. Respiration, adaptation, it goes on the list. And then the story of precision. However, I've said this already, so I won't repeat it. Let's look at science-specific language learning opportunities, because there's a balance. Yes, there's challenges, but also one of the things is when you look at a science textbook, it's not just words. It has diagrams, it has graphs, it has tables of data, it has maybe equations, right? And dealing with all of these things actually helps interpret the language. But again, in the language arts class, a student has never learned that there's 5 sources of information, and now I have to coordinate them all to come up with a common understanding of what this book is telling me. So how do I look at the picture and the caption under the picture, and I look at the graph and the caption under the graph, and I look at the text, it's in paragraphs, and I put it all together to come up with a single understanding of what this book is telling me. That's not something you're going to learn any place outside of a science class. And it has to be supported for all students, and particularly, but it provides a path into reading the text for the language learner, because they've got other sources of related and similar understandings that are not just verbal. And therefore they help make that connection to the verbal text. The other thing, which for language learners is, science is rich in different topics to explore. Whether I'm doing physics or I'm doing biology, even in the context of a physics course, I'm going to bring up many different phenomena, and therefore many different areas where there's vocabulary to be learned. And so the diversity of topics being explored broadens the language learning opportunity, and you don't have to artificially introduce some vocabulary because you want it learned. You introduce it in the context of you need it to talk about this problem. And then doing design opportunities, design work, which would put engineering in with science for multiple reasons. One of them being that for students coming from families where science has not been part of their background and culture, the fact that science is useful in the real world and that we use it to support designing new things is an important reason to want to learn science. So the design opportunities also bring with them language opportunities, because students who are designing things really want to tell other people what their design is and why they think it will work the way it works. So again, the design work gives motivation for language development. So, as I've said, I'm going to refer you to a document which helps see this. Let me go. So here's one of the science practices. this actually comes from the paper that was mentioned that I developed with Guadalupe Valdez and Roki Lee, saying when students are doing a science task, such as developing a model to explain a particular system, what do they have to do? Well, they have to do some thinking tasks, which is what's called analytic tasks up here. They have to develop and represent an explicit model for a particular system in order to explain a particular phenomenon. But as they do it, they have to do language tasks. They have to listen and read, and they have to speak and write. In order to describe their model to other students, to compare their model with the model another group of students has developed, to discuss strengths and weaknesses of models. So there's a lot of language tasks associated with doing this science task. This table comes from our paper, but then the document which I referred to on the website of the Council of Chief State School Officers, they have a table like this for every one of the science practices, for every one of the math practices in Math Common Core, and for every one of the language arts practices. I think the language arts standards call them something, other than practices, they call them student qualities or something like that. I forget exactly the terminology, but the point is these tables help the teacher know, are these students doing this practice? But they also help the teacher think about what are the language tasks I'm asking the student to do, right? If a student has to be able to take another student's description and understand it in order to respond to it, that's a language task, right? As well as a science task, so it's one task. So thinking about these science and math practices in terms of the specific language demands of doing each practice, I think is very useful. And that set of tables provides a starting point for a discussion with teachers about what their students are doing or not doing in the classroom, and how language support is needed to help particularly language learners undertake tasks like this. So that's useful. Here's an example of modeling, right? You know, there's not a lot of work. This is an assessment task, actually. So it asks the students to label. You can't quite read it, but the idea is the student is given the picture of a gas in a little lens, and this is what the magnifying glass, if you had such a good magnifying glass, sees, to look at what's going on in the gas. And the students are modeling here. But they have to write some specific words to describe the symbols in their model. Just writing the key to the model, that's a language task, right? So the whole game of building up how you describe what it is you're trying to communicate with this diagram shows that even when you're doing diagrammatic work, it's developing language as well as developing science understanding. We have ammonia molecules, that's language. Right? So, challenge for the teacher is to take what they know about science and science learning and to integrate it into it and learn to think about, well, what are the language demands of what I'm asking my students to do as they're learning science, and how can I support students at varying levels of language to do those tasks, just as I think about how do I support students at varying levels of science understanding to do those tasks. It's a big demand on the teacher, and it doesn't work to just say, here's what you do for language, and here's what you do for science. You really have to say, here's what you do to support language development in the science classroom for it to work, and then teachers can get it and really run with it, because it's not about language for the sake of language, it's about language for the sake of learning science. That's the way the science teacher sees it. But for the student, who cares? If I'm learning something, I'm learning something, right? So this is the message I'm trying to convey. This is about, well, how do you do it? First, you set up a good science situation. Right? something which will stimulate the discourse, something that the students want to explain. And then you support the discourse and think about it, and flexibly and differentially arrange student groupings in different parts of the task. And you prompt and question to elicit student thinking, but also at the same time you're eliciting student speaking. And so the whole process is very, very rich in terms of the opportunity it provides. And where it has been done with attention to using science for teaching language, it is demonstrated that this works. That this really is a powerful way, not only of supporting science language, but of supporting language learning. And math learning too, if you integrate that in at the same time. So like, depends on the task, depends on when you ask for it. But the idea that, particularly at the elementary school, where one teacher is teaching everything, it's not about language time and science time and math time all separate all the time. Yes, sometimes they have to be separate and the focus has to be, this is a math exercise, this is a problem designed to elicit certain math learning. And over here, this is a science problem that's designed to elicit certain science learning, but both those problems can also elicit language learning and reading ability development and literacy development. So figuring out how you do all of this together is, and it's different like at the elementary school where one is trying to teach them all, and at the high school level where the focus of the teacher is generally much more disciplinary based, but they have this range of language learner levels in their classroom and need to figure out how to support all of them to learn science. Okay, so I think my time is up, and I just leave you with a few more statements about what science teacher can do to support language learning. It's rich, it's varied, and it just takes paying a little attention to that piece of what's going on in your classroom, as well as to the science learning you're trying to elicit as you design the activities and groupings and culture in your classroom to make the science learning work. You can think about what also it can do in terms of language and literacy learning. I will stop there and let you ask your questions. Yes.
So you had mentioned that science notebooks can be written in students' home languages, which allows the students to think through before they do their formal writing. What do you suggest for pre-lyric who come in without writing skills?
Diagrams. Right. Starting with express your idea whatever way you can. And then, okay, what words do you need? Tell me what's in this picture. And maybe we need to provide you with a few of those words and show you how to write them. And of course, it's really hard at the high school level if you have kids coming in without the literacy, even in their home language. Then that challenge is much larger because those kids have developed an education deficit that takes a lot of work for the teacher to overcome. So I'm more thinking about the kids who, when they arrive, have some level of literacy and some level of math and science even in their home schooling and their schooling before they came to your school. But yes, for the kids who arrive at high school pre-literate, that's a real challenge. Different challenge than the pure language learning challenge. Because they have so many other learning challenges as well. Thank you.